Hi, good day. My name is Dr. Jason William Vitalis. I would like to present a paper entitled Applying Value Stream Mapping for Process Improvement and SME Case Study. To start with, the abstract of this paper refers to the introduction. For any manufacturing company, every service offered involves significant costs. In order to sustain in the highly competitive market, most of the operation departments in the companies are not only putting huge efforts to reduce costs of the service offered, but also striving to cut down the cost of production. These organizations also need proven concept for reducing lead time and the tools to do so if they want to remain competitive. One of the methods is called lean manufacturing. The main principle of lean manufacturing is to reduce waste in operation, material, lead times, and defect. For this study, TIMSB, an SME of pipe manufacturing company based in Sabah, were chosen. In order to visually display where waste occurs in the process, a value stream mapping VSM is drawn. VSM is a direct observation of the simple process of information and material flow as they are currently occurred by summarizing them visually and then envisioning a future state with much better performance. This study focused on one of the product family. There were 5 value-added activities, 8 necessary but non-value-added activities, and a non-value-added activity were identified. A total of 89% difference with a production lead time of 1,925.9 minutes and value added time of 198.6 minutes. A significant 70.8% of reduction in lead time from 1,925.9 minutes to 561.5 minutes with the introduction of full system supermarket, 5S, and total productive maintenance. A total difference of 64% with a production lead time 561.5 minutes and the value added time to be remained at 198.6 minutes. That is 25% reduction has been achieved. With this rapid growth of sales, manufacturing sectors nevertheless are expected to be able to keep pace with technological progress in order to remain strong in the global market. As stated by the Small and Medium Enterprise Corporation Malaysia in 2007, the challenges facing by SMEs in the light of the changing global market are the ability to compete globally, move up the value chain, and embrace ICT and e-commerce. These challenges are actually closely interlinked. In order to compete on the basis of quality, cost, reliability, and speedy delivery in the global market, SMEs must reap economies of scale. Therefore, researcher is interested to examine the potential of VSM as a tool to improve the quality of production process in manufacturing industries of SME in Sabah. VSM is one of the tools in lean manufacturing that is said a proven approach for success in manufacturing industries. It is also widely used by the manufacturing industry to identify and eliminate waste, improve production time, and reduce production costs. Even though lean manufacturing is a proven approach for success in manufacturing industries, but in the case of SME in Sabah, the use of VSM to improve production process are very rare. Therefore, this study is hoped will be a benchmark for future study in using VSM as a tool to implement lean manufacturing. Downtime in manufacturing is defined as any period of time when a machine is not in production. A total amount of downtime a factory experiences includes any stops during production that cause a loss of revenue for the company. So what are these ways referred to? Let me explain briefly through this abbreviation. Defects. Producing defective parts or products will result in rework, scrap replacement, production, and invariable add significantly to manufacturing costs. Overproduction means producing more and faster than needed. Waiting. Waiting time is an idle time that is produced when two dependent variables are not fully synchronized. Non-utilizing talent is not effectively or not at all utilizing valuable resource, that is, the employees. Transportation occurs when people, product, equipment or information move too often or further than needed. Inventory can be defined as any supply in excess of process requirements necessary to produce goods or services just in time. Motion is any movement of people which does not contribute added value to the product or service. Overprocessing can be defined as an effort which adds no value to product or service. In this study, starts with the literature review on lean manufacturing and the use of visual stream mapping as lean tool to eliminate waste. This is followed by the selection of suitable manufacturing organization to carry out the implementation study. Thus, TIMSB has been chosen as the site of study. Upon receiving approval to conduct the study from TIMSB, using a research instrument of observation, document reviews, and interviews, researcher conducted a case study at the site. Researchers studied the existing products and processes followed by the organization and collected the production data for the development of the current state map. Next, the researcher analyzed the data collected from the current state map in order to derive a proposal for future state map. Researcher constructed the future state map, and finally, the derivation of inferences based on the conducted case study. Based on the observation during the first week factory visit, TIMSB has 5 groups of production lines which vary from the type of production and diameter range. The location for all production lines are shown in Figure 1. This TIMSB production flow plan. The first 3 lines produces unplasticized polyvinyl chloride or UPVC pipes, whereby line 1 within diameter range from 15 mm to 110 mm, line 2 within diameter range from 80 mm to 250 mm, line 3 within range from 15 mm to 50 mm. On the remainder lines, line 4 only produces HDPE within the diameter range of 20 mm to 250 mm, while line 5 only produces garden hose. This Figure 2 shows the summarization of TIMSB production flowcharts. The data collection for the material flow started at the production department. Towards the delivery, gathering snapshot data such as inventory levels before each process, process cycle times, numbers of operator, shift and changeover times as summarized in Table 1. Figure 3 shows the current state value stream map. It has been observed that significant scope for improvement is there. as particular part waits for 1925.9 minutes, and the real value addition time is only 198.6 minutes. In summary, 5 value-added activities, 1 non-value-added activities, and 8 necessary but non-value-added activities were identified. There are 5 potential improvements can be suggested from the current state value stream map. The main reason of lean manufacturing is to support in improving customer satisfaction all the way through the whole VSM. From current state VSM, researchers found out that the inventory and lead time need to be addressed as both are equivalent as to be reduced by identifying the suitable lean manufacturing tool and creating an ideal VSM. Figure 4 shows the future state value stream map. From the analysis, researchers proposed 2 types of lean tools. Firstly, the full system supermarket, 5S, and total productive maintenance. For full system supermarket, researchers proposed to apply in 3 stations, namely weighing station, the mixing station, and the finished product store. As for 5S, it is applied to weighing station, mixing station, recycle station, to store and finished product storage. And finally, a total productive maintenance is mainly for machineries, that is, the vacuum machine. The full system supermarket is considered as the space allocated for storage products that are ready for delivery, which usually located at the end of the production process. The supermarket is introduced to make sure every product starts to flow rather than to wait other material to be prepared in large amount, which create unnecessary inventory to the next station. Furthermore, it is able to create continuous flow and retain by switching to other product, in essence to ensure no machine or operator is in neither idle position nor product is waiting. The need of 5S program is proposed for these particular areas. Initial start for this program would be the tool store, mixing station, and the recycle station. However, 5S does not endorse additional worker to the workstation, but instead requires existing worker to perform these tasks and utilizing 5S practice as a habit in daily work. By taking pictures of before and after performing 5S would motivate everyone for the improvement made throughout the process. Thereupon, the communication between workers and workstation is improved, subsequently increase the productivity and the quality. Next, TIMSB will gradually eliminate any occurrence of abnormalities in the equipment conditions that are frequently ignored and delayed for an extended time. Furthermore, with less failure frequencies, may improve machine uptime and reliability, plus unnecessary overhauls which involve costing. After all, by changing to a total productive maintenance environment can significantly reduce random machine breakdowns and in turn inventory and lead time. Simple visual monitoring would directly improve the availability of the machine. Overall, the researcher managed to show the benefits of implementing VSM as an effective tool to improve production times and process in TIMSB. Table 2 shows the lean tools solution proposed in TIMSB. The study concludes with the findings of significance, about 70.8% of reduction in lead time, from 1,925.9 minutes to 561.5 minutes, with the introduction of the full system supermarket, 5S, and the total productive maintenance. A total difference of 64% with the production lead time, 561.5 minutes, and the value added time remain as 198.6 minutes. That is 25% reduction has been achieved.